This video is about using SPSS for doing McNemar's test. The McNemar's test is a pair sample test for categorical. So this is an example. A program is designed to promote people to join public health profession. And we like to know, is there a significant change in the percentage of people who wish to join public health profession after applying this promotional program? So a group of participants were asked through a survey whether they would consider public health as their career preference or not, and the survey was done twice. The first one was done before the use of promotion program, and the second one was done on the same group of people after the use of the promotional program. In this study, of course, the null hypothesis is that there's no association between the promotional program and the people's preference, career preference in joining the public health profession. And alternative is that there is association between the two variables. That means the use of this promotional program does help changing people's the career preference in joining public health profession. And the following is the data collected, the result of the survey. Totally 144 participants. Before the promotional program, there were 25 say yes, and then 119 say no to the public health profession. And after, there are 46 say yes and 98 say no. So the counts of yes increased from 25 to 46. So there's some change. We want to see whether this change is statistically significant. So first of all, we like to enter this data using SPSS. We're going to use weight cases option in SPSS to help us to use this contingency table to create the data. So create the data. I first want to create 4 possible joint cases. The first one, I'm going to use 1 indicate yes and 2 indicate no. So first variable, let's consider that as before variable, and the second is an after variable. So the first variable, let's say I have yes and yes, and a no and no. Okay, second variable is for after. Now I'm going to report this information for yes. So there's a case that the before is yes and after is yes, right? There's before is yes and after is no. There's before no after yes, and there's a before no after no. So again, variable 1 is before and variable 2 is after. Let's change this variable name to before, and let's change it to after. Okay, let's come back to this. So actually we create 4 cases. Yes, yes, that's these 9. Let me put a frequency right next to it. Yes, no, that's these 16. And then no, yes, that's these 37 cases. And then no, no, that's these 82. So we create 4 cases and then just put in the frequency right next to these 4 cases. Let's call this third one frequency. Okay, so after we've done this, we can actually use the frequency column to weight these 4 cases, right? So do that, click data, weight cases, and then select frequency as the weight cases by, and then check that in here. So we weight the cases by frequency column. So after you've done that, SPS will assume that you actually have 144 total total cases. 9 of them belongs to this, 16 belongs to this category, and so forth. Of course, I can code these as 1 as yes and code 2 as no, right? If you would like to do that, I'm going to label them. 1 is yes, and 2 is no. So that's labeled for that. I can right click this, copy and paste the same thing to the second one, second variable. So I got these 1 and 2, and I can view their labels, right? So anyway, I have the data set up ready. I also have the cases weighted with this frequency. Then I can run the McNemar's test, right? To do that, I click Analyze, Descriptive Statistic, Crosstab, and then I will just use the before as a column variable, after as row variable as shown in the table, And I click on statistic and then choose McNemar's. That's the test option to choose. And I click continue and then OK. I will get the frequency table. That's exactly what we had earlier. And it will calculate the McNemar's test statistic p-value, which is 0.005. So the p-value is quite small. Right? And so this p-value is less than 0.05. That means we're going to reject the null hypothesis and support the alternative. So there's some association between the promotional program and people's preference. And this result here is using binomial tests. Okay, when sample size is large, there's actually a asymptotic test, chi-square test for it. So the outcome should be pretty similar in this situation.
Now, the actual chi-square statistics based on this discordant pair. If its chi-square statistics is calculated, its value is 7.55. So it tests actually at degrees of freedom 1. So if we use an Excel worksheet to solve this problem, to get the p-value using chi-square, actually we just use the chi-square distribution right tail with a chi-square score 7.55 degrees of freedom 1. The end result is 0.006, which is very close to the outcome from the binomial test. Now, you create this frequency column variable because you have organized data. You have these frequency information. So if instead you have the raw data, right, you can use these before and after variables directly without having to have this frequency variable for weighting your cases. Right? You can just go ahead, just use these two variables to run the McNemar's test using the same procedure that we've gone through.